Okay, so last time we learned about simplifying radicals. So today we're going to now talk about operations on radicals. So we're going to take it one step further, and we're going to be adding, subtracting, multiplying, and dividing radicals. Before we start, let's make sure we're all on the same page. So this, which we learned last time, this little number on the outside is called the index. Okay, so it could be like 5, 4, whatever. That's the index. Now, what's under the radical is called the radicand. Now, radicals are only like terms if they have the same index and the same radicand. So just like with other like terms that you've encountered before, the only time we can combine them, like add or subtract them, is, in this case with radicals, only if they have the same index and the same radicand. So now that we're on the same page, let's keep going. So we're going to start with adding and subtracting radicals. So there are two major steps. So you're going to first simplify all radical expressions. So that's all the stuff that you learned last video where you simplified. And then after you simplified everything, you're going to add or subtract like expressions, whatever they tell you to do. So simplify. If you're still not sure how to simplify, you should go back to the day 2 video and brush up on that. Otherwise, we're going to keep going. So, all right, we have 4 terms in this first one. So we have 3 square root of 5 minus 5 square root of 2 plus 10 square root of 5 plus 4. So think to yourself, which ones are like terms? Well, I see 2. So there's the 3 square root of 5 and the 10 square root of 5. These both have the same radicand. Remember, that's the whatever's under the radical. And then they also have the same index. So we can combine them. So if we have 3 square roots of 5, and then we have 10 square roots of 5, then they end up being 13 square root of 5. And then we still have this minus 5 square root of 2 that can't combine with anybody else, and then this 4. So we'll just add them on the end. Okay, so that's the first one. So now we're going to take it one step further, and we're going to bring in more simplifying. Because if you realized, this first one, we didn't do any simplifying, so we're going to take it one step further. So, number 2. The square root of 72 needs to be simplified, and the square root of 98 needs to be simplified. This 4 square root of 2 is already most simplified, so we won't need to simplify that. So, square root of 72 simplifies to 6 square root of 2. And we also have this 7 in front, 7 minus that 6 square root of 2, which replaced the square root of 72. Plus 7 square root of 2, which came from the square root of 98. Again, if you're not sure how we got these, go back to the day 2 video where it talked about simplifying radicals. And then we also have this minus 4 square root of 2 and this plus 4 on the end. Now, we have 5 terms here, and so you have to double check, see which ones are like terms. So, for me, to help me out, I like to circle the like terms, and then I'll know which ones to simplify. So this one has an index of 2 and a radicand of 2. This one has an index of 2 and a radicand of 2. This one has an index of 2 and a radicand of 2. So those are all like terms. We can combine these 3 terms. So we have a negative 6 square root of 2 plus a 7 square root of 2, and then a minus 4 square root of 2. So we end up with negative 3 square root of 2. And then we have this 7. That's just a number with no radical. And then we also have this 4. That's just a number with without a radical. So we can combine those. So 7 plus 4 gives us 11. So our final answer is 11 square root of, nope, just kidding, 11 minus 3 square root of 2. Okay. Now the next one involves variables. But we do it in the same way. So I'm going to give you a moment to try it. I know it might be a little bit intense, but I want you to try it. So you simplify it the same way like you learned in day 2. And then we'll let you simplify it. And then, so you can pause it, simplify it, and then come back. So I'll give you a moment to simplify that. Okay, so you should have gotten this after you simplified. So remember, the x's are still under the radical because there weren't enough x's to pull out. And so now we have to look for our like terms. So all three of these have 5x as the radicand. But are they all like terms? No, because one of them has an index of 3. These two, remember, if there's nothing there, it's a 2. So these two have the same index, this one and this one. But the one in the middle, I'm going to circle this whole thing, has an index of 3, so that cannot be combined with the other two. So we'll combine this 6 square root of 5x and this negative 4 square root of 5x, and that becomes 6 minus 4, so that becomes 2 square root of 5x. And then the other two, this negative 4 cube root of 5x and this negative 5 don't have any that they can combine with, so they just come along for the ride. So we have minus 4 cube root of 5x and this negative 5. So that is adding and subtracting in a nutshell. You'll get lots of practice in class tomorrow, so prepare for fun times. And then we're going to move on to multiplying and dividing. So multiplying and dividing radicals. We can only do this when the index is the same. So actually it doesn't matter what's under the radical. It doesn't matter what the radicand is. It just matters that the index is the same. So what you're going to do is you're going to first simplify all radical expressions. I'm actually going to change this to all expressions, so just simplify everything first before you go further. Then you're going to multiply or divide the terms outside the radical, whatever's outside, and then they're going to stay outside. And then you're going to multiply or divide the terms that are inside the radical, and then they're going to stay inside. And then finish it off, then you're going to simplify. So let's take a look at this one. This looks a little complicated, but all you need to know to start this off is a 4-letter word called FOIL. Okay, so you just multiply it like normal. So the first one's 3 times negative 4, still negative 12. Okay, and then you have outer, so this 3 times this 6 square root of 5. So if you notice, 3 doesn't have a radical, so it's on the outside, and then 6 is outside of the radical. So you multiply those, and they'll stay outside. So 3 times 6 gives you plus 18. And then 3 doesn't have a radical, so you're just going to bring the square root of 5 down for the ride. Okay, so we did outer, now we have inner. So we do this negative 5 square root of 5 times this negative 4. So negative 5 and this negative 4 are the ones on the outside, so you'll multiply them and they stay outside. So that turns into a plus 20. Now, negative 4 doesn't have a radical, and square root of 5 does, so just bring the square root of 5 down for the ride. And then the last one we do last. So negative 5 square root of 5 times 6 square root of 5. I'm running out of space here, but negative 5 and the 6 are both outside, so we'll multiply those. That turns into a negative 30. There's a square root of 5 here, and there's a square root of 5 there. And they're both inside the radical, so we're going to multiply them. And then they'll stay inside the radical, so that's 5 times 5, which is 25. Now we're going to simplify. So, do you see anything that we can simplify? I do. This square root of 25. So square root of 25 is 5. So we're going to substitute 5 in for that. So we actually have, on the end, we have a negative 30 times 5, which is just a negative 150. And then we need to bring down the other ones because they still have to come along for the ride. So we have a negative 12. We have a plus 18 square root of 5. And we have a plus 20 square root of 5. Okay, so we'll just bring them down to the bottom line because we're down there. So negative 12 plus 18 square root of 5 plus 20 square root of 5. Okay, but the question is, are we finished? The correct answer would be no. We still have to combine like terms. So, can we combine like terms? Which like terms do you see? Well, there's an 18 square root of 5. So now we have to pull in that adding and subtracting radicals knowledge that we just acquired. So 18 square root of 5 plus 20 square root of 5. Remember, they have the same radicand, so they both have 5 here. And then they also have the same root. Remember, if there's nothing there, or the same index. Remember, if there's nothing there, it's a 2. So we can combine them. So you have 18 square root of 5 plus 20 square root of 5. So that turns into 38 square root of 5. And then, do you see any other like terms? This negative 150 and this negative 12. So we combine those and we end up with negative 162. Then our final answer is this. 38 square root of 5 minus 162. Okay, so now number 6 is a little bit different, but I'm going to let you try it so you'll apply the same principles and then we'll talk about it together. Okay, so give it a shot. Okay, so if you multiplied everything together, remember you multiply what's on the outside, so that's this 5 and this negative 3, and you get this negative 15, and then you have this 3xyz and this 3y cubed z on the inside, so you multiply those two together, and then you put them on the inside, so you end up with 9x y to the 4th, and then z squared. Now, what you do now is you have to simplify what's under the radical. So this is like going back to the day 2 step. So we can split it up as what's under the radical as square root of 9 times square root of x times square root of y to the 4th times square root of z squared. Now square root of 9 is going to be 3. Square root of x, remember you have to, if it's under a square root, you need things in groups of 2 to take them out, but x is just by itself, so he just stays inside. Now, y to the 4th, you can split into 2 groups of 2 y's each, and then you can pull that out, so that becomes y squared. And then z's, you can group them into one group of 2, so that's a z on the outside. Okay, so now don't forget about this negative 15 on the outside. We'll bring that down. Then, conventionally, you would put what's in the square root on the end, so we'll move that over here. So that'll be square root of x over here. And then you can clump everything else together. So you have this times 3, this y squared, and this z. So our final answer ends up being negative 15 times 3 is negative 45. This y squared times z, and then the square root of x. And that's our final answer. Okay, 2 more to go. All right, so let's go back up to this square root 5 times the square root of 144x over 9. Now, the first step, if you look back up here, it says to simplify all expressions. So let's do that. So inside we have the radical, or inside we have a fraction, so we can simplify that one first. So we'll just take this 5 along for the ride. So under the square root, we have 144 divided by 9. Well, both of them are divisible by 9, so we can pull out a 9. Then this becomes 1. Pull out a 9 up here, and that becomes 16. So then we end up with 16x over 1, which is the same thing as square root of 16x. Then we still have this 5 on the outside, so we'll bring that down as well. And then all we have to do is simplify. So we can break it up to 5 times the square root of 16 times the square root of x. 16 actually turns out to be a perfect square. So square root of 16 is just 4. So you have 5 times 4. Remember, for square roots, you need to group things in groups of 2 before you can take them out. But there's just one x, so he has nobody to group together with, so he just stays inside. So we end up with 5 times 5, which is 25, square root of x, and that's our final answer. And then the final one, number 7. Looks complicated, but you follow the same steps. Now, if you remember back to day 2, there was a trick that if you have 2 radicals, one in the numerator and one in the denominator, you can actually put them under the same radical. So we could rewrite this as 4 over 2, this 4 is over here, and this 2 is over here, and then these both have an index of 3, so we can divide them. So we'll just put them under the same radical, and we have 27 x squared over 9x. Now, 4 divided by 2, or 4 over 2, we can simplify that too. So 4 divided by 2 is just 2. Then let's take a look at what's on the inside. Can we simplify anything? We can. So 27 divided by 9 turns into 3. And then we have x squared over x. What can we do with these? Well, the exponent here is 1, and when we're dividing things and they have the same base, so both of these are x's, we subtract the exponents, so we're left with just an x to the first power. Now, is this fully simplified? Can we pull anything out? Can we simplify anything else? Well, no, because 3 just hanging out by itself because there's nobody else it can group with, and then x is hanging out by itself because it doesn't have anything that looks exactly the same as it that it can group together with. So our final answer is 2 square root of 3. And that's it. Not so crazy, right? So that's it for multiplying, dividing, adding, and subtracting radicals. Have fun tomorrow in class.